Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Good, so last session we have made some progress here. There we go, step by step. Step by step. Good, so the MachO reader. We wanted to tackle this to-do now. Okay, so basically we now have classes, get variable name without context name, short variable name. Context name, function index. Yeah. So when it's in a function, we can also put another assert here. We basically, no, we don't need an assert. Okay, so basically if yeah. So we know it will have a context name. By the way, we should probably here say to make it more understanding, boor has context name. Or just has context name. And then essentially we could do the same here. So if it has a context name, then class, yeah, so I think what we do is we create const boor has context name. I wonder, maybe we should. So in function here we have declare context name. Maybe we should have the same base name function base name. Variable. How about we put here an std string, variable deckel context name, variable. And then we call this maybe base name. Yeah, how about that? The context name. Context name of this variable. Base name. Get variable name without context name. And then what we do is short variable name, move, short. Variable dot m variable deckel context name. So basically has context name, if this dot size is not this dot size, right? And then we say if has context name, then we do full variable name dot data plus data size plus 2 and variable base name dot size. And then we can put an assert. This equals this dereferenced equals that plus 1 plus 0. That looks like we have an error here. Yeah, so as context name. Yeah, let's put a breakpoint in here. I think we can remove this one here. No? Did we want to check something still? I'm not sure. Okay, what do we have here? Moved object. Right. Has context. This and this. This. Okay, let's see if it compiles. So basically we now also store the context name for the variable, the same way we have it for the function. Okay, so has context name because this one is contained in this, yeah, so it's contained in this function. And so, by the way, what happens if the, no, that can't be. Yeah. Good, so, oh, that is an assert. Why? 24 mname. Oh, right. Yeah, this is wrong. We're looking at we're looking at const size t context len equals this size minus, by the way, can probably say, how about we say this one is expected to be larger than this. Here, his context name. So here, name is larger than this. Then we do the same here. Name sub str, parent name. Parent name is variable name size minus this size minus 2. Variable name. Well, maybe we don't need this assert there. We can just have it a one-liner like that. Okay, that should work now. Let's see. We are missing here something. Okay, let's try that. Good, has context name. This name is larger than this one. And now the decal context name is this one, yeah. Which is this function. Actually, couldn't we, if we have a get variable name without context name. Should it be possible to also function? Let's put an assert here. Function dot mname mname equals variable decal context name, right? I expect that this will be always true. Yeah, good. Let's put that together. Maybe we move. Yeah. Okay, and then here we say if is known class if name to class index if shit. How do we do that? Name space. Name to class index. Can we assign an iterator and at the same time check it? Yeah. Yeah. IT. I think what we can do is if name to class index. So string to index map iterator it equals that dot find name, and then we do it not end variable name to class index. So we take this and that. Yeah. Yeah. Okay. And then do else if, and then we do another for name to namespace index, variable decal context. There we go. Yeah. Okay. So in here, let's put a breakpoint. So in here should be if it's part of the class, and here if it's part of a namespace, right? Yeah. Okay, that hits. That's good. C stream sound variable stream sound is open callback. Yeah. That's good. Let's see another one. Let's go to watch it. Let's see stream another one. Close callback. Yeah. Pixel shader manager, mpixel shaders, OpenGL, and we also got some in a STL prime list. Okay, that seems to work. Bezier segment, yeah. Special power field pass. Okay, that looks very good. Yeah. Very good. Yeah. Okay. Then it's a bit complex condition. Yeah. Let's add some comments here. This function, well, let's say a variable in function, variable in class, variable in namespace, and global variable in file, and static variable, let's say local static variable in file. Okay. Okay, let's try to fill that in. Asserts and debug prints, yeah. Yeah. Good. So variable in class. So what do we do? So we have an iterator, and the iterator gives us a second. That's the index. So we're looking at class type equals m classes it seconds. Class type namespace namespaces. Code namespace type. There we go. Good. And then we basically say namespace type dot does the namespace also need a concept of global and not global? Oof. Not sure. Maybe. Yeah, probably. Let's do class first. It's probably easier. Class type. Child variable indices dot pushback variable index and variable dot parent class index is it second. Yeah, so namespace. So in principle, it's the same thing here. Yeah, parent namespace index, but variable indices. Direct variables in this namespace, not contained in classes. Direct functions in this namespace, not contained in classes. Oof. Oof. Yeah. Yeah. Global. Namespace. I think it should be the same how we do it here for file. Yeah, probably. Yeah, so how do we say variables defined in the source file, global variables referenced in the source file? Yeah. I'm not sure. Maybe the namespace shouldn't contain any global variables. Only the source file contains global variables. And so, because it's only reference, right? It's only reference. Yeah. Oof. But it will have a parent. But we can still... Shit. I'm not sure. Maybe it helps to see some samples. Yeah, let's put a breakpoint here once more and let's take a look at some samples that we get in. Yeah. Like, do we, for example, get a global variable in a nameset? Probably. Probably. Okay. So here we have, what is this? Okay, so STL prime list. STL prime list. Okay, that doesn't tell me much here. It is an S, it's not a G. Let's see some other. Here's a G. Huh. Game client random variable. Okay, but this could be a class here. This could be a class. By the way, if we already classify variables here into classes and namespaces, then that means that this check won't work either here, because I mean static variables can be inside namespaces, right? So I don't think that we can do this check here. Like, just because there's a static member doesn't mean that it is a class, right? Or does it? Probably not. Okay, but so we have a G. It's probably in a class. This game client random variable is probably a class. Yeah. That is interesting. Yeah. Yeah. Okay, let me hold on. Let's variable. Let's search for this one in here. There we go. Game client type names. Yeah. Yeah. Hidden, yeah. Set range. Distribution type. Okay, let's search for distribution type names. Here. Yeah, so this is it's not in a function, it's in a file, random value cpp. Yeah. Distribution type names. G. Yeah. Okay, so G just means it's being used in there. Yeah. Data. Variable in namespace. Well, it doesn't make sense to add multiples. Hold on. No, yeah, we just added once. Yeah, variable namespace. Yeah. No, I think this is correct then. Yeah. 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 It seems correct. Okay, can we move this? Okay. Yeah, I think this is correct for starters. Yeah. Okay, let's see if it runs through without error. That works, yeah. Okay, that's good. Variable indices, yeah. Yeah, so regarding this to do, oh, is it somewhere? Yeah. Check if there's static memory variables class. Yeah, but I think that doesn't. I mean, it could be a namespace or class. No. I think that doesn't help. No. No. Has template, syntax expensive. Used in function argument. Indicated in name. Yeah. Yeah, we need to revisit this later here. Okay, but I think this one is not applicable. Let's think about it once more. A static variable can be inside a namespace or inside a class. Yeah. Yeah. Yeah, I think that we cannot use that. No. Good. Okay, so step 1 here looks pretty good. Maybe we say here 1 add new variable. 2 update and verify existing variable. Yeah, so basically there needs to be a second step because there can be multiple records of this coming in, right? Yeah. So, yeah. Okay, that will be the next effort, but I hope that this is all correct now and we gathered all the good information. Yeah. By the way, maybe we should rename description to ID. Yeah, I think we can do that. MID. Yeah. And then we remove this here. Then we see what the next compiler is. ID. MID. Meh. Okay. 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 So basically the update will be, we need to do something here. We need to assert a bunch of things. Yeah. Yeah. Add new variable. Yeah. Okay. Okay, so first step is MID. So we have IT second, right? That's the index. So variables. Oh my gosh. There we go. IT second, and that is variable. Oh my gosh, variable equals that, and verify existing. So actually we can do it like we had done it here. Let's do that. So here we have, wait, hold on, do we want to out? No, we just index t, const index t, that thing, we remove this comment. So do we probably should verify name, right? Yeah. What is the name here? Name, full variable name. Short variable name. Let's use the short variable name. So use string view, short variable name. Short variable name is symbol dot name function index. We should probably do or I think let's take a look at variable once more. So parent source files referenced by source files, parent namespace class function. Parent class. Oh boy. Ah, shit. What do I do? Oh boy. Oh boy. Oh, the variables are really complex, I have to say. So the problem is there can be a global version of the symbol and a non-global version when it's a static initialized or static uninitialized one. So there comes the type, yeah, type. Yeah. So how are we have bool m is global, false. Yeah. Let me say this variable is used as global variable. Let's say not confined in CPP, not confined in single CPP. Okay, so it's global, and then here, let's put this here as global. And then we remove this here. Then we put here You can also make these flags here. Yeah. So we say this is 1, 0. Let's say type unknown 0. One, 2. Then we make it enum var type. We say var type. Then we start with var type unknown, and then it's not and she's is used as global variable, is not confined in CPP. Okay, then we remove this here again. We start with unknown. We make it a u and this. We don't say it's obsolete. And then say is global. We say mtype var type global. Okay. And then here var type let's call this var type. Yep. Okay. Glaube. And then here we say type is that. Yeah. Var type. And we say here if type is global, yeah. Var type. There we go. Okay. So here we would probably variable, we would assign var type right? And we probably assert variable var type. So it shouldn't be the case that here n var type nah. Here, this one. uninitialized is not that. Mutually exclusive types. Why is this complaining? Somehow it's complaining. I don't know what the problem is. Ah, variable. There we go. There we go. Okay, so we expect that the MID is the description where we use that, and we can move that. Okay, so we expect to name this. So here we are looking for the short name, so we will expect that the variable base name equals short variable name. And the short variable name we get how? I think we just look for this here. Short variable name is this one here, without context name. Const. Yeah, and then here we say symbol dot name. Then we can delete all this. That should work. Okay. So we just assert here a bunch of types thingies. Okay. Good. Apart from that, we also need to fill. We need to fill more things. Okay, so names we don't care. They should be the same. Address. Address. Well, we can do const uint 64t address equals symbol value variable name. How about we put this here in here inside the assert? Okay, let me put assert variable dot maddress. Either it's hold on. If variable dot maddress is 0, which would happen if it was a global, right? Then we need to update the address. Address equals similar value. Yeah. And then so our assert is that the address is either hold on, equals 0. Okay, so we either assert that this is 0 or these two match. All right. Yeah. Yeah. I think that is correct. Yeah. The more asserts, the better. Then we have more confidence that everything works to our expectation. How about we already take a glimpse at this, if this looks good so far? No, it does not. Let's see, what's the problem? It's global var type. There we go. Variable var type. Actually, here we should. Yeah, var type is okay. Oof. Oof, 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 oof. Var type. There we go. Okay, that works. Um, 04 variable var type 2. Yeah, okay, 2 var type. So this is now an update. Hold on. So variable is this one. Var type 2. It's not a global. Yeah. Print. Okay. Address is not 0. Okay. Oh, we got a hit. Uh-oh. Var type. Okay, I'm a bit surprised that this is complaining. Huh? Why is this complaining? The goal is that we mask var type with these two, and it should never match these two together. Or am I seeing something wrong here? Huh? Huh? Two or 4 is 6. Yeah. So what's the problem here? Var type is 2. 2, this is not this. Huh? I don't understand. Probably some really stupid error. Oh. Hold on. Wrong button. Okay, so var type, let's be extra stupid, yeah? So this, and we take these two. Oh, where did it go? variable dot m var type 2. See? And these two, they will be 6. 6. And 2 is not 6. What's the problem here? Huh? I don't get it. I don't understand. Huh? That makes no sense. That makes no sense. 2, 2, 4. 2, 4. I don't get it. Okay, let's comment this out for now. I'm confused. Let's hope that at least the other ones will pass according to the expectation. The section maybe not. Section may be failing. Yeah, we'll see. Oh, that is also failing. What the hell? Symbol scache digmap v. Oh. Right. Mangled. Let's say name, let's say mangled. Maybe unused. Cons. Oh, we were get there. Yeah, eventually. Good. So mangled is that, and that should match now, and it does. Section matches. Good. Address is either 0 or the address matches. Yeah. Okay, let's check the next one. Yeah. Okay, let's see if that runs through. No, it does not. Okay. Okay, looks like the address has a mismatch. Yeah. 16 seconds per logic. Oh. Descriptions receive. Right. So a variable can have multiple addresses. I see. Yeah. Well, that is unpleasant. That is unpleasant, yeah. Yeah. Oof. So the problem is each source file has their own copy of this specific variable here, and therefore has its own address. But all of these will probably have this exact same value, right? Uh, hmm. Hmm. Mm. Mm. Maybe we should have a variable variant like we have for function variants. We have that concept as well. So we have an overarching symbol, but then we create variants for it. Yeah, yeah. Mm-hmm, mm-hmm. 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 Yeah. Mm-hmm. 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 Yeah, I think that's the best solution. Mm. So variable, let's see how we did it for function. So here we have a variance, function variant, and that contains the address. Huh? Ah, you're in 60. Yeah. Mm. Instructions, function instruction. Huh? What is this thing? Why is there another address here? What? What? What is this thing? I already forgot what that is. Instruction. The CPP file. Huh? M at. Huh? I'm confused. What did we do here? What the hell is that? Why are there multiple ones? Why is there an address? What? I'm so confused. What has happened? Why is there an address here and then there's another address? So we definitely set the address here. I don't understand what this is. There's another address. We probably should have put some comments there. Function address. That's outrageous. Let's put a breakpoint here. I'm really confused. What's going on? What did we do here? Game memory.h. Oh, function instruction. Right. Right. Okay. Okay. Let's add a comment here. Instructions. Instructions that map to a source line. By the way, doesn't this mean Simba? Instruction that map to source. Begin of function. begin of source line, begin of address to begin of function, address to begin of source line. I think that makes sense. Okay, so we have function. Okay, but we shouldn't worry about this right now. We should worry about variables, if we can find them here. Okay, so basically we would have a struct variable variant, and that would contain an address. So this one here, address, and then that's it. Right? No. The variant. This one here. Yeah. No. Ugh. But it can also be part of these. But then there's only one address. Oh, how do I design this bullshit? So basically we only will have multiple variants when it is not in a class and when it's not in a function. Only if it is in source files, because then there can be each having their own copy, yeah. But if it's in a class on a variable, that should never happen. Yeah. Okay, I need to think about how to design this, because yeah, I think I need a break here. Yeah, I'll take a break, and then next we need to think about this here. Yeah. Okay, but I think it was a good session. We made a little bit of progress. Good. Then I wish you a great day or night. Until next time, goodbye.